Good morning, class. My name is Dipti Mishra. I am your PGT teacher. Here, I came to teach you a small topic on chapter Haloalkanes and Haloarenes. We know that in chemistry, total we have 10 chapters. In that, 3 are from physical chemistry, 2 are from inorganic chemistry, and 5 are from organic chemistry. In that, Haloalkanes and Haloarenes is our first chapter. Now we will go ahead. We will see that we will see that introduction, that basically what is haloalkanes and haloarenes. So basically, haloalkanes are those compounds in which one or more hydrogen atoms of an alkane chain are replaced by an halogen atom. For example, you know that CH3, CH2, and then CH3. This is our normal alkane. In that, if we will replace one hydrogen, either from this or from this or from this, by an halogen atom, X. X is our halogen atom. Either it can be fluorine, chlorine, bromine, or iodine. These are known as halogens. Here, I want to tell you something that why they are known as halogen, why fluorine, chlorine, bromine, and iodine, they are known as halogens. Basically, this halogen word, it is made up of two words, halo and the gen. This halo means, this halo means sea salt. This halogen means sea salt. And this gen means formation. This gen means formation. So basically, these are known as halogens because these elements, these elements we use for the formation of salt. The best example is for Cl, what we can form? NaCl, that is common salt. So that is common salt. So chlorine is used as a to form the salt formation. That's why fluorine, chlorine, bromine, and iodine, they are known as halogen. This name is taken from the Greek language. So what I was saying, that this is your plain alkane chain. In that, if we will replace either one, two, or three hydrogen atom by an halogen atom, then it is known as the haloalkane. In the same way, when in a ring, when in a ring, we will replace, when in a ring, we'll replace one hydrogen atom, one or two hydrogen atom by again halogen atom, then that ring structure, it is known as haloarenes. Ring structure is known as haloarenes. Again, halo means from where halo came? From halogen. Arenes means a ring structure. Arenes means ring structure. Clear? Now, classification, how we can divide them. So based on the number of halogen atoms, see, we can replace one hydrogen atom, we can replace two hydrogen atom, we can replace three hydrogen atom, and so on. So if you will replace one hydrogen atom, it is known as a mono. Mono means one. If we will replace two hydrogen atom, then di. If we will replace three, then tri, and so on. Polyhalogen atom. So if we will replace one hydrogen atom by one halogen atom, then it is known as a monohalogen compound. Mono, why? Because one halogen, because of that particular halogen compound, and then compound. Same, if we will replace two hydrogen atom, then it is known as di. If we will replace three hydrogen atom, then it is known as tri, and so on. Now, based on the types of carbon atom, see, first of all, I want to tell you for what is primary, secondary, and tertiary. For example, this is our normal alkane. Okay. In that, we are replacing one hydrogen atom by an any X. X can be fluorine, chlorine, bromine, and iodine. Halogen we will replace by X. So now, new structure will be CH3, CH2, then CH2X. Clear? Here we can see that this X is attached with one carbon atom. This carbon atom is attached with again, one another carbon atom. So basically, when halogen is attached to one carbon atom, depends on this carbon is attached with how many other alkyl groups. How many other alkyl groups? So if you will see here this carbon from which this halogen is attached, this carbon is attached to only one this alkyl group, only this alkyl group. So it is known as one alkyl group. So it is known as primary. So it is known as the primary. In the same case, if this X is attached with this carbon atom, in place of two hydrogens are there, we will replace one more hydrogen atom, and in place we will add another alkyl group. So basically, carbon is attached to this X, and then this carbon is attached to another carbon atom. This, sorry, it's not from here. This we will attach hydrogen here, and then it will attach to another alkyl group. Then it is known as a secondary carbon atom. I hope you will get it. Again, when this carbon atom is attached with three alkyl groups, then it is known as the tertiary. So basically, it depends on that halogen is attached to carbon atom. That carbon atom is attached to how many other alkyl groups. On this basis, it is known as primary, secondary, or tertiary. Here one question is there. Basically, what is this alkyl group? So basically, you have alkane chain. Alkane can be anything. You know that CnH2n plus 2, that is the general formula of alkane. From alkane, if you will replace one hydrogen atom, it is from alkane. If you will replace one hydrogen atoms, then it is known as alkyl group. For example, CH3, CH2, CH3. Normal alkane chain, propane. Clear? If you replace one hydrogen atom, it is propane. We know that IUPAC name is here propane. Why propane? Because three carbon atoms are there. If you replace one hydrogen, it will become CH3, CH2, then CH2. This is only known as propyl. Basically, it is alkyl group. Alkyl means that depends on number of carbon atom, it will get propyl, butyl, like that. This is only your alkyl group. Okay. Now, based on the types of halogen, I told you total four halogens are there: fluoro, chloro, bromo, iodo. So it depends on which halogen atom is attached to that particular compound, we can name them. For example, fluoro. Then fluoroalkane, chloroalkane, bromoalkane, like that. Now, if you will see nomenclature, that IUPAC nomenclature and common nomenclature, you know that nomenclature is very important. So how you will name them? First of all, that some rules are there. In that first rule is, we have to identify the longest chain containing halogen. First, we have to identify which is the longest carbon chain. In that halogen is attached. Number of chains so that halogen get the lowest number. Here, for example, you have CH3, CH2, CH2, and then CH2, Cl. Clear? For naming, we can start from 1, 2, 3, 4. Okay? Or you can say, ma'am, I will start from here. 1, then 1. One second. So nomenclature, we were seeing nomenclature. So, or we can start naming from 1 here. That is 2, then 3, and then 4. This is your second carbon atom. This is your first carbon atom. So you can numbering from the above side also, or you can name them as below side also. But in according to this, what it is saying that number the chain so that halogen gets the lowest number. If you will start from the above side, from this top side, then only halogen will get the lowest number. That halogen is present at first position. If you will below that down method, then halogen is our fourth position. That is not correct. If you follow that this method so that halogen should get the lowest number. Now we will add prefix fluoro, chloro, bromo, iodine. Depends on which halogen element is there in your compound. In that we will name them. For example, if you want to name them this compound, then what you will have? One chloro, how one chloro, one chloro. How many carbon? 1, 2, 3, 4. One chloro, butane. The name will be 1-chloro-butane, like that. Prefix, we are using chloro. Why? Because chloro is there. Butane, because we have 4 carbon atoms. For example, CH3Cl. Here we have chloromethane. At first position, you can write 1 or you can avoid it also. No problem. So chloromethane, because you have 1 carbon atom, methane. Chloro is there, that's why chloro. And again here, CH3, C6H5Cl, chlorobenzene. Why? Because on benzene ring, you have 1 chlorine. Clear? Now, method of preparation. How basically we can prepare? So for haloalkanes from alcohol, we know that this OH group is known as alcohol. So alcohol plus HX. HX, it means that hydrogen halide. HX, it means that hydrogen halide. Again, it can be fluorine, chlorine, bromine, and iodine. So basically, this X is your fluorine, chlorine, bromine, iodine, hydrogen halide. Halide came from halogen. What it will form? It will form haloalkane plus water. Now from hydrocarbons, it will go to free radical halogenation. I hope you know what is free radical. That if in a compound, if chlorine, if for example, we have chlorine, chlorine will break this bond. So both the electrons, one electron, it will go on the both the side. Then this method is known as free radical. After that, we have haloarenes. So how we can prepare haloarenes from benzene? Electrophilic substitution with halogen in presence of Lewis acid. For example, FeCl3. Ferrichloride, it is known as the Lewis acid. So in the presence of Lewis acid, electrophilic substitution reaction will happen with halogen, then haloarenes will form. Later on, we will see mechanism. Now, physical properties. Boiling point increases with increase in molecular weight and size of halogen. Why? Because of because of increase in surface surface area surface area. That's why boiling point increases. Now, then density, haloalkanes will have higher density than alkanes. Why? Because in haloalkanes, we have heavier atoms. Fluorine, chlorine, bromine, they are heavier atoms. Now, solubility. They are insoluble in water and soluble in organic. Why? Because haloalkanes are polar molecules. Here it is written polarity, polar molecules. Polar molecules, it means that charge separation can happen. For example, Rx. This is your haloalkane. Here R is having plus charge, X is having negative charge. So it is a polar molecule. And we know that water H plus OH minus. Water is also having a polar molecule, and we know that like dissolves in like. Like dissolves in like dissolves in like. So basically, polar molecule will dissolve in polar molecule, non-polar molecule will dissolve in non-polar molecule. Now, chemical properties. Nucleophilic substitution reaction. Nucleophilic substitution, it means that nucleophile will come and substitute. What is nucleophile? Which is having the negative charge, and it will get attracted by the protons by the nucleus. So nucleus will come and substitution reaction will happen. It will happen by two mechanisms, SN1 mechanism and SN2 mechanism. In SN1 mechanism, the rate of the reaction will depend only upon one reactant, and in SN2 mechanism, the rate of the reaction will depend on the two reactant. Clear? Elimination reaction. Elimination, it means that to eliminate, to delete, to avoid. So formation of alkane. So basically in haloalkane, one of hydrogen atom and X, that is halogen atom, they both, it will eliminate and double bond will come, that alkene. Reaction with metals, formation of organic metallic compounds like Grignard reagent, RMGX. So with the help of this reaction, chemical properties, that reaction will happen with metals and we will see Grignard reagent, organometallic compound. So I hope you would like this class. Thank you so much.